Hello friends, this is Keval Patel and today we discuss about Miller cycle. You will learn about Otto cycle, diesel cycle and dual cycle and also about Atkinson cycle. And today we discuss about Miller cycle, which is work on the Otto cycle and also as well as on diesel cycle. The background of Miller cycle is he, he was patterned by Ralph Miller, an American engineer, dated on 24 December 1957. The engine may be a two-stroke, four-stroke, and diesel fuel. Mazda is the only known manufacturer that successfully produced a Miller cycle engine from 1995 to 2002 on a Mazda Millennia 2.3-liter V6 engine, and currently in Japan 1.3-liter Mazda 2. Okay, and other manufacturing such as Subaru are nowadays working on prototypes engine. The next one is Miller cycle highlights. The inlet valve closing is delayed and part of the air goes back into the intake manifold. Expansion ratio is increased without increasing compression ratio by changing the shape of the piston. Why we are using the expansion ratio changing without increasing in compression ratio? Because we get the power in due to into the expansion stroke. Okay, and if we increase the compression stroke, there is the chances of detonation. Okay, that's why we didn't increase the compression ratio, but we want more power. That's why are going to increase the expansion stroke. Okay, so without increasing in compression ratio by changing in shape of the piston, the inlet valve closing is delay and we don't change the in compression ratio. Excellent output power and scientific power. Thermal efficiency improves without risk of knocking and pumping loss, as we discussed before. Actual compression stroke occurs in the later 70 percentage to 80 percentage of the compression stroke and NOx reduction. Okay, here we can see in this figure, in most of engine the compression ratio is equal to the expansion ratio. Compression ratio, all you already know that the ratio of the volume of the air fuel mixture in the cylinder before and after the compression stroke, and expansion ratio, the ratio of the volume denoted fuel before and after the expansion stroke. But into the Miller cycle, we here you can clearly see that the we didn't close the inlet valve. Okay, that's why we reduced into the volume of during the compression stroke, and as remaining in compression stroke, you can see into the expansion ratio is increased by reducing the combustion chamber minimum volume. In current MZR engine and Miller cycle engine, you can see clearly the difference between the combustion chamber. Okay, difference in combustion chamber volume before expansion. And there are four cycle. The first one is isentropic compression, second one is constant volume heat addition, third one is isentropic expansion, fourth one is constant pressure heat rejection. Thank you. I hope you would like my lecture.